Welcome to Next Round Coding. Today we're going to solve jump PM4. The problem states that given an array of integers ARR, you are initially positioned at the first index of the array. In one step, you can jump from index I to index I plus 1 or I minus 1 or a j where error of I equal to error of j and I not equal to j. Return the minimum number of steps to reach the last index of the array. Notice that you cannot jump outside of the array at any time. So let's understand the problem first. So the problem states that we are currently standing at the index 0 means the first index and we need to go to the last index means the index 8 here. To go to 0 to the last index we can take three types of jump. Type 1 I to I plus 1, type 2 I to I minus 1 and type 3 I to j such that error of I equal to error of j and I not equal to j. And as well we need to minimize the number of jump to reach 0 to the last index. Okay, for this case, from 0th index, we can go to 1 index by type 1 jump, right? If we take type 2 jump from 0th index, it will go out of bound, right? Okay. Now, from index 1, we can again take type 1 jump, right? And same for index 2 as well. This way, we always able to reach the last index. But as the problem states, we need to minimize the number of jump. What can we do here? So from index 1, if we take the type 3 jump, then from index 1 we can directly jump to the index 7, and from index 7 if we do the type 1 jump we can directly go to the last index, the index 8. So how many jumps we are taking here? Here is one jump and here is another one and here is another one. Total 3 jumps we are taking here to go to the index 0 to the index 8, and it will be the minimum for this case. So we will return 3 here. So this is the example 1. So we are standing at the index 0. The value here is 100 and we need to reach the last index means the index 9. To do that, first of all we can do a type 3 jump here. From 0 we can go to index 4 because index 4 have 100 and 0 have 100. So from index 0 we can directly go to the index 4. Now from index 4 we can go to index 5 by type 1, and from index 5 we can go to index 7 by type 2, sorry, type 3, and from index 7 we can go to index 8 by type 1 jump, and from index 8 we can go to index 9 by type 1 jump. And if we do so, the jump we are taking here is 1, 2, 3, 4, 5. 5 jump we are taking here. But we need to minimize the jump. So check the other possibilities as well. So if we jump like this one from 0 to index 4, now from index 4 we can jump to index 3 by type 2 jump, right? Now from index 3 we can directly jump to index 9 by type 3 jump, right? Because in index 3 we have 404 and index 9 we have 404. So if we do so, then jump we are taking our one jump, here is another one jump, here is another one jump. We are taking three jumps here. As we need to minimize the jump, so the minimum number of jump we can take to reach from 0th index to ninth index is 3. That's why the answer will be 3 here. So as you can see, there are many possibilities to go to the last index from the 0th index. So if we need to minimize the jump, then we need to check all possibilities here. To check all possibilities, we can simplify the problem as a graph problem. So if we mark the indexes which have the same elements, then we can find out which index we need to go for type 3 jump. So for 100 value, we have two indexes 0 and 4. For minus 23 value, we have two indexes 1 and 2. For 404, we have two indexes 3 and 9, and for 23, we have three indexes 5, 6, and 7, and for 3, we have only one index, index 8. Now we know which indexes are connected to each other. Now we can do a simple BFS and check the minimum jump we need to take to go the last index from the zeroth index. So for the BFS, we need a queue data structure which will take the index and the steps, and we need to take a visited array of same size which will mark which index are visited and which are not. So first of all, we need to push the zeroth index in the queue. So we need to push the zeroth index in the queue and with the steps of 0 and update our visited array to zeroth index to 1. Now from the zeroth index, if we do the type 1 jump, then we can go to simply the next index in the index 1. So just pop the first index from here and put the index 1, and with the step 0 plus 1 means 1. And from 0 to index, we can also go to the previous index, means the minus 1 index. But if we go to the minus 1 index, it will be out of bound. So we don't need to push into the queue. And from the 0th index, we also go to the index 4 because 0 and 4 are already connected. So from 0, we can go to the index 4 with the steps of 1. Right? Now, make the index 1 as visited. Also make the index 4 as visited. Now pop the index 1. When we pop the index 1, we can simply push the index 2 here for type 1 jump with the jump of 2. We can go the 0th index by doing type 2 jump, but if you see the visited array here, it is 1 at the 0th index. That means 0 is already visited, so we don't need to push 0 here. But from the 1th index, we can go to the index 2 because 1 and 2 are connected to each other. But by doing the type 1 jump, we already marked the 2 as visited, so we don't need to push the index 2 in the queue. Now pop the next one. If we pop the next one in the index 4, from index 4, we can go to the index 5 directly with jump of 2. We can go to the index 3 with jump of again 2 plus 4 to 3 by type 2 jump, and from index 4 to index 0 as well. But 0 is already visited, that's why we no need to go to the index 0 and mark the visited array of index 3 and 5 as 1. Now pop the index 2. If we pop the index 2, we can go to 3 and we can go to 1. But 3 and 1 is already visited. So no need to push anything in the queue. Now pop the index 5. If we pop the index 5, we can go to index 6. Index 6 is not visited. So just push 6 with a jump of 3. We can go from index 5 to index 7 as well. And 7 is also not visited. So make 7 and 6 first of all visited and push 7 with the jump of 3. From 5 we can also go to index 4, but index 4 is already visited. So no need to push index 4 here. Now pop the index 3. If we pop the index 3, we can directly go from index 3 to index 2 and 4, but index 2 and 4 are already visited. And from index 3, you can directly go to the index 9 because 3 and 9 are already connected to each other. Index 9 with jump of 3, right? So make index 9 visited as well. Now pop the index 6. If we pop the index 6, you can see the 5 and 7 is already visited, and from 6 we can't go any other positions. So that's why for 6 we know don't need to push anything. Now pop the index 7. If we pop the index 7, we can see that 6 is visited but 8 is not visited. So from 7 we can go to 8 with jump of 4. Mark the 8 with 1, and from 7 there is no other possibilities. Now we will pop index 9. When we pop index 9, we can see that index 9 is already the last index. So no need to go further. Whatever step with the index 9, that will be our answer. So for this case, 3 will be our answer. I hope you guys able to understand the approach over here and the BFS as well. Okay, now let's see the code. So first of all, we need to know the size of the array. If our array size is 1, we just return 0 because our first index is our last index. That's why we don't need to take any jump. Now we need a map to store the connected indexes. Map of int vector. Just store the connected indexes. MDP of error of I dot pushback I. Now we need to create a visited array. So a vector of int vis of same size initialize with 0 and a queue of pair and comma int queue. And in the queue we need to push the 0th index with steps of 0 while not queue dot empty. Now check the front element. There will be an index and there will be steps. And pop it out. Now if our index is last index, we'll just return the steps. Now if index plus 1 is lesser than n and visited array of index plus 1 is 0, then we can just push index plus 1 with steps plus 1 as a pair. And mark the visited array. Now do the same for index minus 1. It will be greater than or equal to 0. Now check the connected indexes. If it is not visited yet, we can push it to the queue with steps plus 1 and mark the visited array with 1. Now after it, we need to do an important step here. MPP of error of idx dot clear, because we don't need to check the same connected indexes again and again. So we can just clear it and it will optimize our time. So at the end, we just return anything, you can just return 0 because we have already returned our answer here. So now just run it. Okay, so the issue here is we need to mark the visited of 0 as 1, and here would be the MPP of ARR of IDX, right? So now just run it. Yeah, it is running fine. Let's submit it. Yeah, it is accepted. Now time complexity of this approach is usually big O of n, and the space complexity would be again big O of n, as we are using a queue and a visited array. And the time complexity here is big O of n because we are visiting each index only one time. So thanks for watching. Thank you.